In 2024, Rio Tinto placed one of the largest haul truck orders in the history of the Pilbara. Over 150 autonomous mining trucks for their iron ore operations in Western Australia. And the number of those trucks painted Caterpillar yellow was 0. Every single truck went to Komatsu. Every last one. The American giant that built modern mining trucking just got shut out of the biggest equipment deal on the planet, and the company that replaced them was Japanese. But the real story is worse than one lost order, because Rio Tinto was not the first mining company to walk away from yellow iron. They were just the latest. To understand how Caterpillar lost the mines, you have to understand how completely they once owned them. From the late 1970s through the early 2000s, if you ran an open pit mine anywhere on Earth, you ran yellow. That was not a preference. That was the reality of the equipment market. Caterpillar did not just sell haul trucks. They defined what a haul truck was supposed to be. The engineering standards, the payload targets, the reliability benchmarks, all of it came out of Peoria. The 793 was the machine that set the global standard for ultra-class mining trucks. 240 tons of payload capacity. A truck so well engineered that mine planners designed their haul roads, their ramp grades, their bench heights, and their loading face dimensions around the specs of that single machine. When a mining engineer anywhere in the world said ultra-class, they meant the 793. That was the benchmark. Every other manufacturer was measured against it, and for 2 decades, every other manufacturer fell short. Then Caterpillar went bigger. The 797F became the largest mechanical drive haul truck on the market. 400 tons of payload. A machine so massive that you could park a full-size school bus inside the dump body and still have room to walk around it. The 797 was not just an engineering achievement, it was a declaration. Caterpillar was telling the global mining industry that nobody could touch them at the top of the size chart. And for years, that was true. Nobody could. During that peak era, the mining division was the most profitable segment inside all of Caterpillar. Not construction equipment, not power systems, not energy and transportation, mining. The margins on ultra-class trucks were enormous because the replacement cycle was predictable, the aftermarket parts revenue was continuous, and the customer base was functionally locked in. If you operated a fleet of 4793s and your maintenance crews were trained on Caterpillar hydraulic systems, and your parts warehouses were stocked with Caterpillar components, and your mine plan was built around Caterpillar truck performance specs, switching to another manufacturer meant retraining hundreds of technicians, rebuilding your entire parts supply chain, recalculating your mine plan, and accepting years of operational risk during the transition. The switching cost was so high that it functioned as loyalty. Mining companies did not stay with Caterpillar because they loved the paint color. They stayed because leaving was too expensive to consider. And the fleet numbers reflected that dominance. BHP, the world's largest diversified mining company, ran Caterpillar trucks across its iron ore and copper operations in Australia, Chile, and beyond. Rio Tinto's massive Pilbara iron ore operations were built around Caterpillar equipment. Vale, operating the Carajas iron ore mine in Brazil, one of the single largest mining operations on the face of the earth, ran yellow fleets. Codelco, the state-owned copper giant in Chile and the largest copper producer in the world, relied heavily on Caterpillar for its open-pit haul operations. Newmont, the world's largest gold mining company, used Caterpillar trucks across its Nevada operations and at mines on multiple continents. The iron from Illinois was everywhere. If you stood at the rim of any major open-pit mine on 5 continents and watched the haul trucks climb the ramp loaded with ore, the color you saw was overwhelmingly, unmistakably yellow. That was the empire at its peak, and every single one of those major fleet operators has since diversified away from it, reduced their Caterpillar commitments, or switched to competitors entirely. The defection did not happen overnight. It did not happen because of a single bad product launch or one lost contract. It happened because the math changed, and mining companies follow the math with the discipline of a religion. The first major crack appeared in the Pilbara, and it appeared because of autonomy. Rio Tinto was one of the earliest mining companies in the world to commit to fully autonomous haulage at production scale. This was not a pilot program running 3 trucks on a test loop. Rio Tinto wanted autonomous haul trucks running real ore across real mines, integrated with dispatch systems and operating around the clock without operators in the cab. Starting in the early to mid-2010s, Rio Tinto began deploying autonomous trucks across its iron ore operations in Western Australia. The technology partner they chose for that rollout was Komatsu. The reason was simple, and it was not sentimental. Komatsu had a production-ready autonomous haulage system called FrontRunner. Caterpillar, at that time, did not have a comparable autonomous system ready for deployment at that scale. So Rio Tinto went with the company that could actually deliver what they needed when they needed it. And once you deploy over 100 autonomous Komatsu 930E trucks across your mine sites, retrain your entire control infrastructure, rebuild your communications network to support autonomous dispatch, and integrate all of it into your production planning systems, you do not go back to yellow. You order more of what works. That 2024 order for over 150 Komatsu trucks was not a surprise. It was the predictable, inevitable outcome of a technology commitment Rio Tinto made more than a decade earlier. Caterpillar lost the Pilbara because they showed up late to autonomous haulage. And in mining, showing up late to the technology your biggest customer needs is identical to not showing up at all. BHP followed a similar path across its Australian iron ore operations. When BHP evaluated autonomous haulage for its largest mines, they found that Komatsu had the operational track record and the production deployment hours that justified the capital commitment. BHP did not abandon Caterpillar across every operation overnight, but across multiple major sites in Australia, the fleet mix shifted visibly. Where the haul roads once carried exclusively yellow trucks, Komatsu machines started appearing in larger and larger numbers. For a company of BHP's scale, even a partial shift in fleet preference represents hundreds of millions of dollars in equipment orders moving away from Caterpillar and toward a competitor. At Vale's Carajás mine in northern Brazil, one of the largest and richest iron ore deposits ever discovered, the story played out differently, but ended in the same place. Vale diversified its ultra-class truck fleet, bringing in Komatsu equipment and evaluating other suppliers who could compete on the metrics that actually mattered. The Carajás mine moves staggering volumes of ore every day, and at that scale, even a fractional improvement in cost per ton moved translates into tens of millions of dollars in annual savings. Vale's procurement engineers ran the full lifecycle cost analysis and concluded that Caterpillar was no longer delivering the best value equation for their specific operating conditions, their specific ore body, and their specific haul profiles. In Chile, Codelco began diversifying its ultra-class haul truck fleet as well. The Chilean copper mines operate at extreme altitude, in thin air and punishing conditions, and Codelco found that competitors were offering haul trucks with comparable power and reliability at a better total cost of ownership for those high-altitude environments. Komatsu and Hitachi, through its EH-series mining trucks, including the EH-5000, offered acquisition costs that undercut Caterpillar, while delivering fleet availability numbers that matched or exceeded the yellow iron in head-to-head operation. Newmont's gold mining operations, anchored in Nevada but extending to sites around the world, followed the same pattern. Fleet purchase decisions that had defaulted to Caterpillar for 20 or 30 years were suddenly going through genuine competitive bidding. And when Newmont's fleet planning teams ran the full cost per ton analysis across the expected operating life of the trucks, the Caterpillar advantage that had existed since the 1980s was gone. So why did all of these operators, spread across different continents, mining different commodities, operating under different regulatory conditions, arrive at the same conclusion at roughly the same time? Three factors converged, and together they shattered the lock Caterpillar had held on ultra-class mining for decades. The first factor was cost per ton moved. Mining companies do not buy trucks the way a construction contractor buys a dozer. They buy the ability to move ore from the loading face to the crusher at the lowest possible cost per ton. That single number includes the acquisition price of the truck, the fuel burn rate per operating hour, the tire wear across different haul road conditions, scheduled maintenance intervals, major component rebuild costs, and, above all else, availability. Availability is the most critical variable in mining fleet economics because a truck sitting in the maintenance bay is a truck that is not hauling ore, and a truck that is not hauling ore is burning money every minute it sits. For decades, Caterpillar dominated on availability. Their trucks consistently ran more hours per year, experienced fewer unscheduled maintenance events, and were supported by the deepest parts network in the mining industry. That availability advantage justified the premium price on every yellow truck that rolled off the assembly line. Mining companies paid more per truck because the trucks ran more hours, which kept cost per ton competitive even at a higher acquisition price. Then, Komatsu and Hitachi closed the gap. The Komatsu 930E achieved fleet availability figures in the Pilbara that matched what Caterpillar trucks were delivering in the same operating environment, on the same haul roads, moving the same ore. The Hitachi EH5000 showed comparable availability performance in South American copper operations under equally demanding conditions. When availability is equal between two trucks, the only remaining differentiator is the price. And on acquisition cost, Komatsu and Hitachi consistently came in lower than Caterpillar. The difference was not a rounding error. On a fleet order of 50 ultra-class haul trucks, a meaningfully lower per-unit cost compounds into savings large enough to fund an entire additional year of fleet operations. Mining procurement teams did not need a sales presentation to see it. They could read the spreadsheet. The spreadsheet said switch. If you work in the industry, or you have spent your career around heavy iron, and this kind of breakdown helps you understand what is actually shifting in the equipment business, consider subscribing to this channel. We cover the equipment decisions, the fleet economics, and the competitive changes that reshape mining and heavy industry. Subscribe so you catch the next one. The second factor was autonomous readiness. Komatsu deployed its front-runner autonomous haulage system at full production scale in the Pilbara before Caterpillar had a comparable system available for commercial deployment. That timing gap proved decisive in ways that will echo for decades. Autonomous haulage is not a software update you install over a weekend. It requires integrated vehicle control systems, mine-wide high-bandwidth communication infrastructure, centralized fleet management software, collision avoidance sensors, and safety protocols that all function together as a unified operating platform. Once a mining company commits to one autonomous system and deploys it across dozens or hundreds of trucks, the cost of switching exceeds anything the conventional truck market ever created. You are not just replacing trucks anymore. You are replacing an entire operational architecture. Rio Tinto committed to Komatsu's autonomous platform early. BHP evaluated the same technology and reached similar conclusions at several of its sites. By the time Caterpillar brought its own autonomous mining truck technology to a production-ready state, the largest autonomous mining fleets in the world were already running Komatsu. The window in the Pilbara had closed. Caterpillar could not win that business back with a slide deck or a price cut. They needed a time machine. The third factor was dealer support proximity. Caterpillar's global dealer network is legendary in the construction world. In virtually any city of any size on Earth, there is a Caterpillar dealer within a reasonable distance. That network is a genuine competitive moat for construction and general earth-moving equipment. In mining, the equation looks entirely different. Mining operations cluster in specific, remote, often harsh geographies. The Pilbara in Western Australia, the Atacama Desert in northern Chile, the Carajas Basin in the Amazon region of Brazil, the Great Basin of Nevada. These are places where parts availability and technician response time directly determine whether a mine hits its daily production tonnage target or falls short. Komatsu and Hitachi recognized this geographic concentration and built purpose-specific mining service centers in the exact regions where the ore comes out of the ground. They staffed those centers with technicians who worked exclusively on ultra-class mining equipment, stocked them with the specific components that mining trucks consume, and committed to parts delivery and response times that matched or beat what Caterpillar could offer. Caterpillar's dealer structure serves construction, power generation, oil and gas, marine, and mining through the same distribution channel. In remote mining regions, where every hour of downtime costs real production tonnage, The competitors built something dedicated. And in mining, dedicated beats general every time. Now, Caterpillar has not vanished from the mining industry. The company still holds competitive positions in specific segments. Their large mining shovels remain strong products in select markets where loading capacity and dig force matter most. In underground mining, particularly longwall systems for coal extraction and certain hard rock applications, Caterpillar equipment continues to perform well and hold meaningful market share. And there are individual surface operations around the world where existing fleet investments, long-term service agreements, or site-specific geology and haul conditions keep the yellow iron productive and cost-effective. Caterpillar is not finished in mining. But Caterpillar is no longer dominant in the product category that defined its mining identity for 40 years. The ultra-class haul truck, the machine that made Caterpillar synonymous with open-pit mining around the world, is now a fiercely contested segment where the company from Peoria is fighting from behind. The Pilbara, once the crown jewel of Caterpillar's mining truck business, is now Komatsu territory. Chilean copper operations that ran exclusively yellow for decades are now running mixed or competitor-dominant fleets. The Carajas mine in Brazil, Australian iron ore broadly, Nevada gold operations. All of them have shifted. The strategic question Caterpillar faces is whether this erosion can be reversed. Can the company invest enough in autonomous technology, in competitive acquisition pricing, in mining dedicated service infrastructure to reclaim the ultra-class segment? Or has that market moved permanently, the same way agricultural equipment and on-highway trucking moved away from Caterpillar in previous decades? The historical pattern is worth examining closely. Caterpillar exited on-highway trucking. The company's agricultural equipment ambitions never reached the scale of John Deere or AGCO. In both cases, Caterpillar chose to allocate capital towards segments with better margin profiles, rather than fight grinding market share battles in categories where competitors had already built structural advantages. If that same capital allocation logic now applies to ultra-class mining trucks, the implication reshapes how you think about this company going forward. It would mean that the manufacturer, founded on the premise of moving earth, has quietly decided that moving ore at the highest scale is no longer worth the investment required to lead. For the mining companies themselves, the switch was never emotional. Mining executives do not wear brand loyalty on their sleeves. They wear cost per ton moved on every quarterly report they file. When Caterpillar delivered the best cost per ton, every major mining company bought Caterpillar and never thought twice. When Komatsu and Hitachi matched the availability and undercut the acquisition price, those same mining companies bought Komatsu and Hitachi without looking back. The trucks in the pit serve the spreadsheet. The spreadsheet does not care what color the paint is. What happened to Caterpillar in mining is a case study in how industrial dominance erodes. It does not collapse in a single dramatic failure. It does not end with a press conference or a product recall. It erodes gradually, through a long sequence of rational decisions made by customers who are doing exactly what they are supposed to do. Optimizing their operations, choosing the equipment that delivers the lowest cost per ton moved, selecting the technology partners who showed up with working autonomous systems when the mine actually needed them, rewarding the suppliers who built dedicated service infrastructure where the ore is, not where the corporate headquarters sits. Caterpillar optimized for something different. The company prioritized shareholder returns, margin protection, and disciplined capital allocation. Those are excellent strategies for generating investor value in the near and medium term. They are also the strategies that lead you to underinvest in the exact products, the exact technologies, and the exact service commitments your largest customers need most urgently. When a mining company calls and says, "We need production-scale autonomous trucks running in the Pilbara," and your answer is that you will have something competitive in a few years, that company calls Komatsu, and Komatsu picks up the phone. This is the third major product segment to slip away from Caterpillar in roughly 2 decades. First, on-highway trucking, then agricultural equipment, now ultra-class mining haul trucks. 3 different product categories, 3 different competitive dynamics, 3 different time periods, and the same underlying cause every single time. The company chose to protect margins rather than protect market position. And by the time the revenue numbers reflected what had happened, the customers had already signed with someone else. The pattern across these three segments is not a coincidence. The pattern is the strategy itself. Caterpillar invented modern mining trucking. They built the trucks that built the mines that built the global commodity supply chain feeding steel mills and smelters and refineries on every inhabited continent. And the mining companies that grew up running nothing but yellow iron, the companies that trained their haul truck operators and their mechanics and their mine planning engineers on Caterpillar equipment, are the same companies now placing their largest fleet orders with Komatsu and Hitachi. The iron from Illinois built the modern mine. Whether it can hold its place inside one is the question Caterpillar still has not answered. If this gave you a clearer picture of what is happening in the mining equipment industry, hit that subscribe button. We cover the machines, the fleet decisions, and the competitive shifts that matter to the people who actually understand this world. Subscribe now so the next video finds you.